So today we're going to talk about parallel line proofs. And the nice thing about parallel line proofs is they frequently are very much the same, especially in terms of reasons. They're the same reasons over and over again. Again, a reminder that more than likely you're going to have a word bank to do these. But I just want to go back over and talk about the corresponding angles of these different types of angles. And if you look at the picture on example 1, we can look at where corresponding angles are. And corresponding angles, first of all, they're in the same place with respect to the parallel lines and the transversal. So if we take a look at this problem here, what we've got is we've got angle 1 is on top and to the left of the transversal, and angle 5 is on top and to the left of the transversal. Those are corresponding. They're in the same place with respect to the parallel line and the transversal. We could do that with angle 2 and angle 6. Those are both on top and to the right of the transversal. And then you could do both on bottom and to the left of the transversal, both on bottom and to the right of the transversal. Those are corresponding angles. Again, just refamiliarizing ourselves with the different vocab words. Alternate interior angles. We even talked about the alternate interior angles when we did the angle sum theorem in our last set of notes. But it says if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Again, we can look at that here. And in this particular case, inside. It has to be inside the parallel lines. So we could say that angle 3 and angle 6. They're in between the two parallel lines, and they're on opposite sides of the transversal. It also works if we go over here. 5 and 4 are alternate interior angles. They're in between the parallel lines, and they're on opposite sides of the transversal. If you're watching the video and you weren't here for the notes, we changed the next word, the vocab word, to same side interior angles. And what that means is if two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. So again, it's interior, so it has to be in between the parallel lines. We take a look at this one, then angle 3 and angle 5. Those are same side interior. They're in between the parallel lines, and they're to the left of the transversal. And if we add those two together, by the way, they would combine to be 180 degrees. The other option is 4 and 6. Those two are also same side interior. They're in between the parallel lines, and they're to the right of the transversal. And then finally, our last set is alternate exterior angles. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are equal. If we look one last time at this picture that we're going to be using for example 1, alternate exterior. So these have to be outside of the parallel lines. So in this particular case, 1 is above the parallel line, and 8 is below. They're outside of the parallel lines, and they're on opposite sides of the transversal. Also works if we do angle 2 and angle 7. They're outside of the parallel lines, and they're on opposite sides. So some old vocab that may come back into play here as we jump down here to our example number 1. And again, the nice thing is that a lot of these parallel line proofs are very, very, very same. And in fact, we can still start our proof like we always do, with our given. Line A is parallel to line M, and that's given, as well as what we're trying to prove. So even if you can't do anything else, you should be able to fill those in. So angle 3 is congruent to angle 6 is what we're going to try to prove. So let's go back and look at this here. And since we're trying to prove angle 3 is congruent to angle 6, we want to make a statement that involves angle 3. And do you have any thoughts about a statement that we can say about angle 3? Back to us. But if we take a look at this, what we can say, we want to make a statement regarding the first angle. So we've got a couple choices. And what I said is that angle 3 is congruent to angle 2. If you take a close look at what angle 3 is and angle 2 is, we see that those angles are vertical. And our reason then we can say is that vertical angles are congruent. Gonna have to abbreviate here. Vertical angles are congruent. But once we know that, then we need to go ahead and we need to make a statement that involves this second angle that we used up here. So we started with angle 3, and the reason that I picked angle 3 because that was the first angle in the part of what we're trying to prove. And since we picked angle 2 here, what I'm going to put is, I'm going to put angle 2 is congruent. And what happens is, it better be congruent to the other angle that we're trying to prove. So if we look back up here at our picture, is angle 2 congruent to angle 6? And it is. They're both on top of the parallel line, and they're to the same side of the parallel line. And what we call that, from our words above, is that corresponding angles are congruent. Got to abbreviate again. And now what we have, we've got angle 3 is congruent to angle 2. Angle 2 is congruent to angle 6. And now angle 3 is congruent to angle 6. We already know that. Sometimes this might help. And I know you don't have a lot of space on your paper, but angle 3 is congruent to angle 2. Angle 2 is congruent to angle 6. And if we think about this, what happens is we transported angle 3 across angle 2. And when we transport that, what our reason here is that it's the transitive, got to spell it right, but it's the transitive property is the reason why. OST, I think every single time that they've tested has asked a question about parallel lines. And the thing about this is, you can get this, you can get this, you can get this. It just so happens that this, the transitive property, is the last statement every single time. So there's 4 blanks that we can fill in instead of 3. And again, you should have a word bank or a drop-down box, a drag and drop or a drop-down box when you're taking the OST. Well, let's take a look at the next one here. And again, once you do a couple of them, they all seem to be the same. Like, these ones blur together in my mind because it's the same thing every single time. So we've got the same picture this time on example number 2. And it says, using the corresponding angle postulate and prove that alternate exterior angles are congruent. And we're given, once again, the same information that we're given last time. That line A is congruent to line M. And we start off with this. We can say that A is parallel to M. That's our given. And we know that the last statement is going to be what we're trying to prove. Angle 1 is congruent to angle 8. But again, the good news is, and I'll change colors here, the good news is that this ultimately transitive is going to be the transitive property. We can fill that in every single time on the parallel line proofs. And if I'm gonna have to guess for the OST, there's gonna be a proof like this on there. So now, when we go back up here, let's start with angle 1. We need to make a statement about angle 1. We've got a couple of options here. We could say that angle 1 is congruent to angle 4. We could say angle 1 is congruent to angle 5. Do you have a preference? So, I'm going to start with angle 1 is congruent to angle 4. Same reason as before. If we look up there, what we see is the relationship between angle 1 and angle 4 is that they are vertical angles. The vertical angles are congruent. Well, now that we've used that, now that we picked that one, then we have to use angle 4, the second angle that we used in our previous statement. And it better be congruent to angle 8, which is the second part of what we're trying to prove. So if we look back up in the picture, is that true? And what we've got is we've got 4 here and we've got 8 there. And what we see is that we've got 2 parallel lines cut by a transversal. Underneath and to the right is angle 4. Underneath and to the right is angle 8. And what those are, same thing that we have up here in our directions, what those are corresponding angles. And again, it's congruent. And they don't change up much. But as we flip our paper over, and actually before I do flip the paper over, once again notice, 1 is congruent to 4, angle 4 is congruent to angle 8, so what's happening is the 1 is being transported across the 4 to give us the angle 8, and that's where the transitive property comes into play. As we flip our paper over, now what we have on the back is we have word bank. And if we take a look at this, some of the stuff is filled in, so we need to be a little bit more careful. Because on this one, it says step 2, our reason says corresponding angles are congruent. So when we look at this one and we make our statement here, I need to be able to use angle 3 or angle 5. So again, when we start this, corresponding angles are congruent. So one of the things that we can say here is, let's do angle 3. Angle 3 is congruent. We need to make angle 3 congruent. Ooh, I can't pick angle 3 because look what I did on that next one. So if we look at our next statement here, it says angle 1 is congruent to angle 3, and let's fill that one in. Go back up there and look, angle 1 is congruent to angle 3. What we see is that these are vertical angles, are congruent, And since we've already used angle 3 in that statement, when we go back to step 2, what I really need to do is I need to pick something with the angle 5. So if we look over here at angle 5, what we see is that angle 5 here is on the top of the parallel line and to the left. And our reason says that corresponding angles are congruent. So I need to put the other angle here that's on top and to the left. So either way that you want to write it, I wrote it angle 1 is congruent to angle 5. If you wanted to write it as angle 5 is congruent to angle 1, you're okay. And I should have filled in at the beginning. And by the way, we should have looked down here at the statements. I didn't even remember that we had a word bank here. But is that one of our options? And it is. We've used that one. So if we take a look here, vertical angles over here we've already used. So vertical angles are congruent. We've used that one. And actually I'll circle that. Our last step here, we could have filled in earlier, is angle 3 is congruent to angle 5. And once again, what we know about all of these parallel lines is that angle 1 is congruent to angle 5. Angle 1 is congruent to angle 3. So we're transporting over angle 1. And when we transport, what we know is that we're working with the transitive property. So we used this one here, and we used this one there. You don't have to use all of them. There's a list, though, that you can use. But if we take a look at this fourth one, you might not even need the word bank. But what we can fill in already is we can fill in that angle 1 is congruent to angle 11. And I don't even have that listed in the possible statements, probably because it's so second nature to write that down. Over here, we know now that every single time we end up with a transitive property. So we've taken care of that. So we just have a couple to fill in. And the nice part on this particular one is it gave us the first statement after our givens. And it says angle 1 is congruent to angle 5. Now a little bit more confusing picture because we've got two sets of parallel lines. We've got R and S parallel, we've got T and U, but let's look at angle 1 and angle 5. Well, here's angle 1, here's angle 5. And seeing the pattern, what kind of angles are angle 1 and angle 5? Well, they're both above the transversal, and they're to the left of the parallel line, which means that this is our corresponding. Corresponding angles are congruent. I'm just going to write congruent there. I'm running out of space. Now, interesting here, for this next one, because look at the words. The reason on this one. It's alternate exterior angles are congruent, but we've already used angle 1, and back up here what we're trying to prove is we're trying to prove that angle 1 is congruent to angle 11, so we need to have something in here that's got angle 11 in it, and we need to also use angle 5. Because angle 5 was used in step 2, and so now that we know to use angle 5, we want to get angle 11. Let's see if I fill it in, if it works. Our angle 5 and angle 11, here's angle 11, I just totally covered it up here, but we'll try better. Here's angle 5 and angle 11. Are those alternate exterior angles? And yes, we're looking at parallel lines T and U. They're outside of the parallel lines and they're on opposite sides. So those are alternate exterior angles are congruent. And then lastly, we've already got that put in there. Again, 1 is congruent to 5. 5 is congruent to 11. We're transporting the 1 across the 5 to give us our transitive property.